Object 279. How the Soviet Union created the most protected tank, capable of surviving even after an atomic explosion. The year 1959. A secret Soviet proving ground. Military engineers and generals froze in anticipation as something unimaginable crawled out of the hangar. It did not look like any single tank in the world. A flattened hull, streamlined like a spaceship, 4 tracks instead of the usual 2, and a turret resembling a flattened hemisphere. Before the astonished commission stood Object 279, a machine created to fight in the hell of nuclear war and emerge from it a victor. To understand why the Soviet Union needed such an unusual tank, one must go back a few years and remember the world in which people of the mid-20th century lived. The Cold War was gaining momentum with each passing year. The United States and the Soviet Union were building up their nuclear arsenals at a frightening speed. By the mid-1950s, both superpowers possessed not only strategic bombs capable of destroying entire cities, but also tactical nuclear weapons for use directly on the battlefield. The Americans developed nuclear artillery and atomic shells that could be fired from ordinary howitzers. Nuclear mines, nuclear torpedoes, and even portable nuclear charges appeared. Soviet military strategists perfectly understood that in the event of a major war in Europe, the enemy would not hesitate to use all available weapons against advancing tank columns. And the Soviet military doctrine of that time assigned heavy tanks the role of a steel battering ram, which was supposed to break through the fortified defense lines of the enemy and open the way for the main forces. The problem was that existing heavy tanks, including the formidable T-10, were completely unsuited for action under conditions of a nuclear strike. The shock wave of an atomic explosion could overturn a multi-ton machine like a toy. Thermal radiation burned out optics and blinded the crew. Penetrating radiation killed tankers even through thick armor. And after the explosion, there remained the so-called nuclear desert, an area pockmarked with craters, littered with debris, and covered in radioactive dust, across which an ordinary tank simply could not move. In the year 1956, the main armored directorate of the Soviet Army formulated fundamentally new requirements for a prospective heavy tank. The machine had to not just withstand hits from enemy shells, but also maintain combat capability. After a close nuclear explosion, it had to traverse any terrain, including territories subjected to atomic bombing. And with all this, the tank had to carry the most powerful armament, capable of destroying any enemy targets. The task seemed practically impossible, but the Soviet leadership announced a competition among 3 of the country's leading design teams. 2 projects were developed in Leningrad at the famous Kirov plant, and 1 in Chelyabinsk at the tractor plant, which during the years of the Great Patriotic War produced the legendary 34s. The Design Bureau, under the leadership of Kotin, took on the creation of Object 277. Isakov's Chelyabinsk team designed Object 770. But the most revolutionary and daring project was proposed by the team of the Leningrad engineer Lev Sergeyevich Troyanov. Troyanov was not just a talented designer, he was a true visionary capable of thinking outside conventional templates. Where other engineers tried to improve existing designs, Troyanov decided to create something fundamentally new. He understood that to solve the assigned task, it was not enough to simply thicken the armor or increase engine power. It was necessary to rethink the very concept of the tank, to start designing from a blank slate. The main problem during a nuclear explosion was the shock wave. It propagated in all directions from the epicenter and carried a monstrous destructive force. An ordinary tank with its angular hull and high silhouette presented an ideal target for the shock wave. It slammed into the flat surfaces of the armor and overturned the machine. Troyanov proposed making the tank's hull as streamlined as possible so that the wave would flow around it without causing harm. Thus was born the famous shape of Object 279, resembling a flying saucer or a seashell. The second revolutionary idea concerned the undercarriage. A standard track system with two wide tracks had one serious drawback. When overcoming obstacles or moving over rough terrain, the tank could bottom out, catching on a stump, a rock, or the edge of a crater. Under the conditions of a nuclear desert, where the Earth is pockmarked with craters and covered in debris, this would mean certain doom. Troyanov proposed installing 4 tracks on the tank instead of 2, arranging them in pairs on each side. Such a scheme completely eliminated the possibility of bottoming out and provided fantastic off-road capability over any terrain. By the year 1957, Troyanov's team had prepared the project, and another 2 years later, the first and only prototype of this amazing machine saw the light of day. When the engineers at the Kirov plant first saw the blueprints for the undercarriage of the new tank, many of them thought Troyanov had completely lost his mind. 4 tracks instead of 2 seemed like an absurdity, a technical excess that would only complicate the design and make the machine unrepairable in field conditions. But Lev Sergeyevich knew exactly what he was aiming for, and his calculations left no room for doubt. On each side of the tank, there was a block of 2-track propulsion units mounted on special longitudinal beams. These beams were not just load-bearing structures, they served as fuel tanks. Such a solution allowed precious space inside the hull to be saved and simultaneously provided the machine with a decent cruising range. Each propulsion unit included 6 dual road wheels without rubber rims and 3 return rollers. The designers placed the drive sprockets at the rear of the tank, which was a classic solution for the Soviet school of tank building. The absence of rubber rims on the wheels might have seemed like a step backward, because by that time most tanks in the world were already equipped with rubberized wheels for a smoother ride. But Troyanov thought in categories of nuclear war. During an atomic explosion, the temperature near the epicenter reaches several thousand degrees. Rubber would simply burn up or melt, leaving the tank unable to move. Steel wheels could withstand the infernal heat and continue to function even after passing through the blast zone. But the main technical miracle of Object 279 was its suspension. Troyanov abandoned the traditional torsion bar system and used a hydrop pneumatic suspension, which in those years was considered the pinnacle of engineering thought. Its principle of operation was based on the compression of gas in special cylinders, where nitrogen played the role of the elastic element, and the damping of vibrations was provided by the flow of oil through calibrated openings. Such a system allowed the tank to literally float over uneven terrain, maintaining a smooth ride even on the most broken ground. 4 tracks combined with the hydrop pneumatic suspension gave Object 279 completely unique capabilities. The tank could traverse deep snow, thick mud, and swampy terrain where ordinary vehicles hopelessly got stuck. It clambered through explosion craters, crawled over fallen trees and ruined buildings. The absence of traditional ground clearance between the tracks completely eliminated the possibility of getting hung up on obstacles. The tank simply could not get stuck on a stump or a rock, because beneath its belly there was no free space where an obstacle could enter. To set the 60-ton behemoth in motion, an appropriate engine was required. The designers considered 2 options for 16-cylinder 4-stroke diesel engines with a capacity of 950 and 1,000 horsepower. Both motors had a horizontal cylinder arrangement, which allowed the height of the engine compartment to be maximally reduced and the overall silhouette of the tank made more squat. This was critically important for protection against the shock wave. After all, the lower the vehicle, the smaller the area affected by the destructive impulse. The selected engine provided the tank with a maximum speed of 50 to 55 kilometers per hour on the highway. For a 60-ton machine, this was a highly respectable figure. The cruising range was from 250 to 300 kilometers, which allowed deep raids into the enemy's rear without refueling. Of course, by today's standards, these numbers look modest, but for a heavy tank of the 1950s, they were more than impressive. Instead of a traditional manual transmission, Object 279 received a single-stream hydromechanical gearbox. The shifting of the top two gears was fully automated, which significantly eased the driver mechanic's work and reduced the probability of error in battle. Operating such a gearbox required less physical effort, meaning the driver fatigued less and could maintain concentration longer in the tense conditions of a tank battle. However, all these technical advantages came at the cost of design complexity. 4 tracks meant twice as many units and mechanisms requiring maintenance and repair. The high-drop pneumatic suspension was a finicky system that required specially trained technicians and special equipment to work with. In field conditions, replacing a damaged suspension element was practically impossible. The tank required factory repair, even with relatively minor damage to the undercarriage. Test drivers also noted increased power losses when moving over soft soils. 4 narrow tracks created more resistance than 2 wide ones, and part of the engine's energy went to waste. In addition, the tank had poor turning ability, making it vulnerable in close combat. Object 279 simply could not pivot in place or quickly change its direction of travel. To do so, it required significantly more space and time than ordinary tanks. But all these shortcomings paled before the machine's main advantage, its fantastic survivability. Troyanov created a tank that could survive a close nuclear explosion and continue to perform its combat mission. A streamlined hull, a squat silhouette, the absence of protruding elements. All this made Object 279 practically invulnerable to the shockwave. The machine was supposed to become the tip of the Soviet armored wedge, breaking through the enemy's defense even under the conditions of a nuclear apocalypse. If the undercarriage of Object 279 staggered the imagination with its unusualness, then its armor protection had absolutely no equivalence in global tank building. Troyanov set an ambitious goal to create a tank that could not be penetrated by any single existing anti-tank weapon, and he succeeded. The machine's hull was a cast structure made of 4 massive steel parts connected to each other by welding. Casting allowed the creation of complex, curvilinear shapes that were impossible to achieve using rolled armor plates. Every curve, every protrusion of the hull was carefully calculated to ensure the maximum ricochet of enemy shells. Striking a rounded surface at an acute angle, an armor-piercing shell did not penetrate the armor, but glanced off it, losing energy and deflecting to the side. But the cast hull was only the first level of protection. Over it, the designers installed thin steel screens of a curvilinear profile, which gave the tank its famous futuristic appearance. These screens performed several functions at once. First, they provided additional anti-cumulative protection. Upon impact, a shaped charged shell forms a white-hot metal jet that burns through armor. But if the jet encounters a thin screen located at some distance from the main armor, the jet begins to form prematurely and dissipates before reaching the target. Second, the screens gave the hull a streamlined shape resembling a giant seashell or a flying saucer. Such a silhouette was ideal for withstanding the shock wave of a nuclear explosion. The wave, encountering a rounded surface in its path, smoothly flowed around it, instead of transferring all its energy to a flat armor plate. Calculations showed that Object 279 could withstand the shock wave from a tactical nuclear munition at a distance that would be fatal for any other tank. As for the armor thickness, the numbers here are impressive even decades later. The frontal part of the hull had a thickness of 250 to 270 millimeters of cast steel, positioned at rational sloping angles. The sides were protected by armor 180 millimeters thick. For comparison, the American M10 heavy tank of the same period had frontal armor of only 127 millimeters, and the British Conqueror had about 152 millimeters. The turret of Object 279 was made in the form of a flattened hemisphere, which also provided high resistance to shells and stability against the shock wave. The frontal part of the turret reached a record thickness of 305 millimeters at an inclination angle of 30 degrees from the vertical. This meant that the effective armor thickness, taking into account the angle of impact of the shell against the armor, was even greater. The rear part of the turret had somewhat less protection, but even it surpassed the frontal armor of most of its contemporary tanks. Such a level of armoring guaranteed complete protection against any single tank gun existing in the world at that moment. Neither the 120mm guns of American tanks nor British guns of a similar caliber could penetrate the front of Object 279 at any combat distance. Even the side armor withstood hits from most anti-tank weapons. The machine was practically invulnerable in classic tank combat. Protection against shaped charge shells deserves a separate mention. By the 1950s, shaped charge munitions had become a real headache for tank designers. They did not require high muzzle velocity and could penetrate armor several shell calibers thick. Anti-tank grenade launchers with shaped charge grenades turned every infantryman into a potential tank destroyer, but the screens of Object 279 reliably protected the machine from this threat, and tests showed that the tank withstood hits from 90mm shaped charge shells at any distance. The most amazing thing was that this entire record level of protection was achieved without the use of composite armor. In those years, experiments were already underway with multi-layered armor barriers, including ceramics, fiberglass, and other materials. But Troyanov managed to achieve outstanding results using only traditional steel armor. The secret lay in the brilliant geometry of the hull, where every square centimeter of surface was optimized to deflect enemy shells. With all this, the weight of the tank was 60 tons. Is that a lot or a little? For comparison, the Soviet T-10 heavy tank weighed about 50 tons with significantly weaker armoring. The American M103 reached a mass of 57 tons, meaning that Object 279 only slightly exceeded its contemporaries in weight, while providing a qualitatively different level of protection. It was a true engineering miracle, the result of painstaking work to optimize every unit and every detail. In addition to passive protection, the tank was equipped with an anti-atomic protection system that sealed the hull and turret under the threat of a nuclear strike. Special seals closed all gaps and openings, not allowing radioactive dust to penetrate inside the machine. A filter ventilation unit purified the air supplied to the crew for breathing. The tankers could continue the battle even under conditions of radioactive contamination of the terrain without leaving their steel fortress. The armor of Object 279 made it practically invulnerable. But the tank was not created just to withstand the blows of the enemy. It had to destroy the enemy. And for this, the designers armed the machine with one of the most powerful tank guns of its time. The main caliber of the tank became the 130mm rifled gun M65, developed specifically to arm prospective heavy tanks and anti-tank self-propelled guns. This gun was created in the second half of the 1950s and embodied all the accumulated experience of the Soviet artillery school. The barrel length was about 7 meters, and the total mass of the gun reached 4 tons. A gun of this caliber turned Object 279 into a true tank destroyer, capable of hitting any armored target on the battlefield. The ballistic characteristics of the M65 staggered the imagination. An armor-piercing shell weighing about 30 kilograms left the gun barrel at a speed of more than 1,000 meters per second. At point-blank range, such a shell pierced through the armor of any existing tank. Not a single Western tank of that time, be it the American M48, the British Centurion, or the French AMX-50, could withstand the strike of a 130mm armor-piercing shell. Object 279 could destroy enemy tanks before they approached the effective firing range of their own guns. To improve firing accuracy, the gun was equipped with a slotted muzzle brake, which absorbed a significant portion of the recoil and stabilized the barrel after firing. In addition, the designers provided a system for purging the barrel with compressed air. After every shot, powder gases remained in the barrel bore, which, upon opening the breech block, could enter the fighting compartment and poison the crew. Purging with compressed air pushed these gases outward, keeping the atmosphere inside the tank fit for breathing. The gun loading process was partially automated. In the turret, there was a cassette semi-automatic loading mechanism that worked in tandem with a crew member. The loader placed the shell and the casing with the powder charge into a special tray, and the mechanism automatically rammed them into the gun chamber. Such a system made it possible to achieve a rate of fire of 5 to 7 rounds per minute, which was an excellent indicator for a gun of such a large caliber. In parallel, the designers were working on a more advanced loading system that could increase the rate of fire to 10 to 15 rounds per minute. But this development remained only on paper. The tank's ammunition load consisted of only 24 separate loading rounds. By the standards of heavy tanks, this was not much, but the dense layout of the fighting compartment did not allow for placing more shells without compromising the crew's protection. Each round consisted of a shell and a separate casing with a propellant charge, which required the loader to perform 2 operations instead of 1. However, the power of the 130mm gun compensated for the relatively small ammunition load. After all, to destroy an enemy tank, 1 accurate hit was usually enough. As auxiliary armament, a 14mm KPVT machine gun, coaxially mounted with the main gun, was installed on the tank. This machine gun combined the rate of fire of a tank machine gun with the armor-piercing capability of an anti-tank rifle. It was intended for combating lightly armored targets, such as armored personnel carriers and infantry fighting vehicles, as well as for suppressing firing points and enemy manpower taking cover behind light field fortifications. The machine gun's ammunition load was 300 rounds. Furthermore, the KPVT could be used as an anti-aircraft weapon to repel attacks by low-flying airplanes and helicopters. The crew of the heavy tank consisted of 4 people. 3 of them were located in the turret: the vehicle commander, the gunner, and the loader. The 4th crew member, the driver mechanic, was located in the front part of the hull in the center. Here also was his hatch for embarking and disembarking from the tank. Such a layout was classic for Soviet heavy tanks and provided good coordination of the crew's actions in battle. To ease the work of the tankers, Object 279 was equipped with the most modern equipment for that time. The stereoscopic rangefinder sight allowed for accurately determining the distance to the target without the need for ranging shots. It had independent stabilization, which meant maintaining the line of sight even when the tank rocked on the move. A 2-plane electro-hydraulic gun stabilizer called Groza kept the gun barrel aimed at the target, regardless of the vehicle's roll and jolts. This allowed for aimed fire on the move, which was a huge advantage in maneuver combat. For conducting combat in night conditions, the tank was equipped with a special night sight, combined with an infrared illumination device. The infrared searchlight illuminated the terrain with light invisible to the human eye, and the sight converted the reflected radiation into a visible image. The range of effective observation at night reached several hundred meters, which allowed for detecting and hitting targets in complete darkness. Many of these devices appeared on serial Soviet tanks only at the end of the 1960s. That is, Object 279 was ahead of its time by almost a decade. The tank was also equipped with fire-extinguishing equipment that automatically triggered when a fire broke out inside the vehicle, underwater driving equipment that allowed for fording water obstacles along the bottom, and a heating system for the fighting compartment for operations in harsh winter conditions. The spring of 1959 became a time of high hopes for Troyanov's team. The only built prototype of Object 279 headed to proving ground tests, where the machine had to prove its combat capability. The tank was driven over rough terrain, forced to overcome trenches and escarpments, and the operation of all systems was checked under the harshest conditions. The powerful diesel roared, 4 tracks ground up the soil, and the 130mm gun hit targets on the proving ground time after time. The tests revealed a series of serious flaws that the designers had suspected even at the design stage. The four-track undercarriage turned out to be extremely difficult to maintain and repair. In field conditions, replacing a damaged road wheel or a torn track was practically impossible without special equipment. Power losses when moving over soft soils exceeded the calculated values. The turning ability of the machine left much to be desired. The tank turned slowly and clumsily. Furthermore, it was not possible to reduce the overall height of the machine, and the labor intensity and cost of production made serial manufacturing highly problematic. However, all these shortcomings were fixable during the refinement of the design. Soviet industry had repeatedly coped with more complex tasks, but the fate of Object 279 was decided neither by engineers nor by the military. On July 22, 1960, at the Kapustin Yar Proving Ground, a demonstration of the newest armored equipment took place for the country's top leadership. Before Nikita Sergeyevich Khrushchev lined up prototypes of heavy tanks, including Object 277, Object 770, and Object 279. The designers hoped that the head of state would appreciate their work and give the green light for serial production. However, Khrushchev was in a peculiar mood that day. He was fascinated by rocket technology and believed that the future belonged to rockets, not tanks. Having inspected the presented machines, the first secretary categorically forbade the military from adopting any tanks exceeding a mass of 37 tons. With a single stroke of the pen, he put an end to all heavy tank projects in the Soviet Union. Object 279, weighing 60 tons, did not have the slightest chance of fitting into these restrictions. Thus ended the history of the most protected tank in the world. The only built specimen headed to the Armored Museum in Kubinka near Moscow, where it stands to this day, astonishing visitors with its fantastic appearance. If you like this story, be sure to leave a like and write in the comments what other unusual military equipment you would like to know about. And do not forget to subscribe to the channel so as not to miss new episodes.